Hello everyone, this is Saad with Aviatrix Deep Dive. In today's session, I'll be discussing about Aviatrix Transit. So prior to discussing the Aviatrix Transit, let's discuss why you need a transit. If you have a couple of VPCs, VNETs, or VCNs, or in short, any cloud network, at this time, you really don't need a transit architecture. And you can get by creating a mesh between your transit VPCs, VNETs, and VCNs. You still have to manage the static routes or the UDRs. But when you have more cloud networks, at that point, you need to create the robust connectivity between them. And also there are some other use cases like centralized layer 7 inspection. You wanted to make sure all your environments like staging, production, development, test, all those kind of different types of environments are completely segmented to each other. You might have some overlapping IP challenges somewhere, and then encryption. And most of it is all about the architecture that Transit is going to provide you. So what is a transit? Transit is the backbone of the cloud networking infrastructure. It provides you the robust connectivity for your applications, whether these applications are within a region, in multi-region environment, multi-cloud, or it's going to connect to your on-prem world using the hybrid cloud connectivity. It simplifies your service insertion. It provides you a common repeatable architecture as well. So Transit connects with the spoke. So what is a spoke? A spoke is nothing but your application cloud network like your VPCs, VNETs, and VCNs. So how can you implement Aviatrix Transit? You can implement Aviatrix Transit by using the UI, maybe the API, or Terraform. It's your choice at that point. All right, with that, let's talk about how can you create the Transit VPC in AWS. So we are going to use the three major clouds, AWS, Azure, and GCP, and we are going to create a transit architecture using that. Today, we will be talking about three major clouds, Azure, AWS, and GCP, how the transit is going to look like, what is going to happen when you create different types of constructs within the Aviatrix controller. So first, you need to define what is going to be the name of your transit VPC. We are going to use an example of AWS Ohio region. And then the CIDR of your entire VPC. I wanted to use the /23. That is the minimum available CIDR for your transit VPC, and there's a specific reason why Aviatrix controller does not allow less than /23 subnet mask for the transit VPC. And we will discuss that when we are going to talk about the high performance encryption or insane mode. So let's say you wanted to name your VPC, the transit VPC, as a transit. And then your CIDR is going to be 10.0.0.0/23. And when Aviatrix controller creates that VPC, it will also create an IGW over here. The name of the IGW will match to the name of the transit VPC, and it's also going to attach this IGW to the transit VPC. There will be 8 subnets that Aviatrix controller is going to create. 4 subnets are going to be private subnets, and these are firewall subnets. Aviatrix controller also going to create 2 public ingress egress subnets and 2 public gateway and firewall management subnet. The subnet mask of all these subnets are going to be /28 in the transit VPC. Aviatrix controller also going to create 2 routing tables. One is going to be private routing table, RTB in short, and then another one, a public routing table. What else Aviatrix controller is going to do when you create a transit VPC from the controller? it's going to create an association between your subnets and then the routing table. So your private routing table, private subnets are going to be associated to the private routing table, while your public subnets, both of them, will be associated to the public routing table. Private routing table will have the subnet prefix over there, the subnet address, and that would be pointing towards the local, because that's a local address. While the public subnet will have the subnet address plus a quad 0, a default route, and that would be pointing towards the IGW. Right? All right, with that, let's talk about what is, by the way, this is, we are talking about the AWS side. All right, so let's talk about what's going to happen when we are going to discuss the Azure. Okay, so when you create the Azure VNet from the Aviatrix controller, then again, you are going to define the name of the VNet. And then there was another construct which is called the resource group. The resource group will be created automatically by the Aviatrix controller in the background, and that would match the name of the transit VNet, which you are going to call it. And the CIDR, AWS calls it CIDR, Azure calls it the address space. That would be something which you are going to assign it to your transit VNet over here. So once you hit create, then it's going to create the transit in Azure. Again, if you wanted to call, or your address space is going to be 10.0.0.0/23, then there will be a resource group that will be created. Now, from the subnets perspective, Aviatrix controller is going to create 4 public subnets. Okay? And then there will be 2 firewall ingress and egress subnets. And 2 of them will be gateway and firewall management subnets. Controller won't create any public routing table or any routing table in the transit VNet over here. All right, so let's talk about the subnet mask of these subnets. So over here, we are going to create all these 4 public subnets are going to be /28. There will be one more subnet, and that subnet is going to be the gateway subnet. All right, so GCP is a little bit different. For GCP, you again log into the Aviatrix controller, you name your transit VPC, whatever you wanted to call it, and then at this point, there is no concept of the address space or the CIDR over there. Everything happens using the subnets that you define. So you need to define the subnets. For Aviatrix Transit, you need to define at least 2 because of Aviatrix Primary and then the HA gateway. So you define your 2 subnets over there, and then also make sure the regions and then the availability zones over there. Aviatrix controller also creates the routes over there. There will be 2 routes similar to the routes that Aviatrix controller created in the AWS and in the Azure environment. So the first route is going to be for your subnet, and that will be pointing towards the local, and then the second route will be your default route pointing towards the IGW and GCP. All right, so let's talk about what is going to happen when you create the spoke in all 3 clouds. I'm going to erase this thing. All right, so you can create the spoke VPCs from your Aviatrix controller as well. Again, as I mentioned it previously, the spoke VPCs are your application VPCs. Controller typically ingest all your spoke VPCs or your application VPCs when you onboard your account. But when you have to create some new, you can create from the Aviatrix controller directly from the Aviatrix controller. The behavior could be slightly different, but the overall idea is the same. It could differ from release to release too. Again, as you created the Transit VPC, you are going to create similarly the spoke VPC. You have to define the name, you have to define the CIDR, and then the IGW is going to be created automatically, will be attached to your spoke VPC. So I'm going to do all that over here right now. So that is your spoke. Let's say you wanted to call it 10.0.1.0/24. The subnet mask over here is /24. From the subnet perspective, Aviatrix controller is going to create the subnets in pairs. And it depends how many availability zones you have. Since we have picked the Ohio region has 3 AZs, so subnets will be created in 3 pairs. So 2A availability zone has 1 private and 1 public subnet. Similarly, 2B will have 1 private and 1 public. Same thing with 2C. 1 private and 1 public. And from the routing table perspective, controller will create 3 pair of routing tables as well. So 3 public and 3 private routing tables. The private routing tables the concept is again the same. It has all the routes of just the local routes, basically, the subnet routes, and then the public routing tables has the local routes plus the quad 0, which is pointing towards the IGW. The subnet mask of all these subnets depends on, number 1, the CIDR of your spoke, and also the number of ACs you have. So since we have /24, then the CIDRs, the subnet mask which we are going to assign to all these subnets, going to be /28 for all of them over here. Okay, so now if you wanted to change this thing, you wanted to say, okay, you know what, I wanted to use a little bit bigger subnet mask. Maybe I'm using /16 over here, maybe /22 or something like that. You can use the advanced options too. If you want it for the more customization, let's say for the gateway subnets, I just want to use /29, while my application subnets could be /27, then at that point for gateway subnets, you can create directly from the cloud consoles as well. Okay, now association works exactly the same way. So all the public subnets, for example, all the public subnets will be associated to these public routing tables per availability zone. So availability zone 2A public subnet will be associated to 2A public routing table. So if I just wanted to write it down over here, these 3 could be something like 2A public, 2B public, and 2C public. Same thing over here, 2A private, 2B private, and 2C private. in this scenario, the 2A1 will be associated here, and then 2B will be associated to this guy, and 2C will be associated to this guy. And same thing with the private also. So Azure works a little bit differently. When you create the Azure Spoke VNet, then you again goes back to the Aviatrix controller and then define your spoke over here, spoke VNet in this scenario, and then your address space. Let's say your address space is /24, and this is a US Central with 3 availability zones. If the availability zone is not there, then definitely you always pick the availability sets for deployment of your gateways. And we will talk about this thing in a few seconds. Controller will also create the resource group that will match the name of your spoke. And from the subnet perspective, controller by default is going to create one gateway subnet. So one gateway subnet, and then it will create 2 private subnets and 2 public subnets. The concept of the private subnet is a little bit different, right? So by default, every single VM that you create in Azure will have access to the internet. How you can make it private is by associating it to a routing table, and in that particular routing table, you are going to define a quad 0 route, and then you point that particular route towards the none. And then this is how it's done. Basically, for example, when you controller creates a routing table, it's going to create 2 routing tables over here, 2 pairs of routing table. So 2 private routing tables, RTBs, where controller is going to say, okay, quad 0 points to none. So any VM you are going to create in these private subnets would not have access to the internet. Controller will also create 2 public routing table, but there won't be any route in there. So and there won't be any route at this time at least. Then the association is going to be exactly the same. So these 2 private routing table will be 2 private subnets will be associated to the private routing table, and 2 public subnets will be associated to the public routing tables like that. In GCP, if we are going to use the example of a GCP US1 with 3 zones in there too, then you need to again define your name of the spoke, create the subnets. You need to create multiple subnets over there for your applications, and also a couple of them for your gateways as well, right? And then Aviatrix controller is going to go exactly the same way as the transit VPC in GCP and creates a routes. The default route points to the internet, and then there is a subnet route also which actually points towards the local. Okay, now I am going to erase this, and when we come back, I'm going to deploy the gateways in the transit first, and then the spoke, and then we will attach these things together and see what happens at that time. All right, so now you wanted to deploy the transit gateways in AWS and Azure. So let's start with the AWS. You have your transit. You want, and it has 3 availability zones. You went again to the Aviatrix controller, and then you start deploying the gateways. You select the VPC, and after selecting the VPC, you wanted to make sure you deploy this thing in public gateway and firewall subnet in availability zone of your choice. Since this is a Ohio region, I'm going to pick 2A for my primary gateway. This is my transit gateway. And then I want to make sure at this point that I have a EIP available for me, because when this gets instantiated, then it will be looking for an EIP, which should be available in your environment. Once you create this thing, then you want to make sure that you create an HA gateway as well. And then the HA gateway, when you create, then you select the different availability zone. In this scenario, I'm going to use 2B. When the second gateway, which is a HA gateway, gets created, controller is going to automatically create a connection between them. This is a tunnel connection, which is created by the controller automatically. After creating these gateways, you want to make sure that you enable the functionality that I discussed in the previous session, which is a monitor gateway subnet. Okay. Now, after creating this tunnel, these two gateways will be able to communicate with each other. Okay, and there is absolutely no change in the routing tables or subnets at this point. Now, if we move over to the Azure environment, the Azure environment is going to be pretty much the same. It also has 3 availability zones. If you don't have the availability zone in the region where you're working, make sure you deploy the Aviatrix Transit gateways or Spoke gateways in availability sets over here. When you're deploying it, you make sure that you're deploying in the public gateway and firewall management subnet. Over here, I'm going to use AZ1 for my primary transit gateway and AZ2 for my HA transit gateway. When the second transit gateway, which is a HA gateway, gets created, controller will automatically create a tunnel between them so they can easily communicate with each other. Again, as I mentioned, there is absolutely no change in the routing tables or subnets. Same thing is going to happen exactly with the GCP also. You are going to create the transit gateways, the primary one and the HA gateway, in 2 different subnets. Now let's take a look at what's going to happen when you are going to create the Spoke gateways in AWS. You already have created a VPC with 3 AZs. You went into the Aviatrix controller and then you pick your AZ over here. Again, my primary gateway, Spoke gateway, in 2A, and my HA gateway in 2B. So exactly the same way as transit, controller is going to create a connection between them using a tunnel. And now when we are going to repeat the same thing in Azure or GCP, it is going to be exactly the same thing. All right, so this would be AZ1, this would be AZ2 over here. And controller is going to create a tunnel between them as well. No change again at this time with any of the subnets and routing table. Okay, so when we are ready to connect the to Spoke to the transit, what is basically going to happen? We deployed the Spoke and then in transit without selecting the high performance encryption or insane mode. That's something which I'm going to discuss in the other session, but things get a little bit changed. The subnets, different subnets are going to be created like /26 and stuff, and we will talk about this thing in our separate session. Okay, so what routing change is going to happen, right? First, let's talk about the both private routing table and then the public routing table in your Spoke, right? So we are talking about the VPC routing table right now. The 2A, 2B, 2C, all these availability zones has a pair of public and private subnets and routing tables. So we are more concerned right now about the routing tables. So for private routing table and public routing table, basically for both, what controller is going to do, controller is going to create RFC 1918 summary routes, which are your 10 routes 172.16, 192.168, all those summary routes will be programmed, and those will be pointing towards the Aviatrix gateways. For example, if you are in AZ2A, then those summary routes, again, I'm going to write over here RFC 1918 summary routes, those will be pointing towards here. And for AZ2, it will be pointing towards the other HA gateway. For the AZ3, it will be pointing towards either the primary gateway or the HA gateway. Similar thing is going to happen in the Azure environment as well. Azure environment has the two pairs of the private and public subnets too. And then we are going to create the RFC 1918 summary over here as well in all three availability zones, and we'll point towards these gateways. Right. The concept of the subnet is different in Azure than the AWS. So subnet actually spans across the AZ. So there will be like, two subnet pairs in this scenario. And then the AZ3 will be one of those public or private subnets. But the end result is you are going to point the RFC 1918 of AZ1 towards the spoke 1, which is your primary, and then the other pair will be pointing towards the HA. All right. In GCP, exactly the same. There is no change so far, right? So the routing tables are not going to be changed. I'm sorry. So the routing tables are definitely going to be changed when we are going to make a connection between them. So let's say when we are going to make a connection, the connections are going to be like this. So this is an active mesh connection, and this is standard encryption. All right, so from the VPC VNET routing tables, we have an idea how the RFC 1918 routes are going to be pointing towards each Aviatrix spoke and in the primary gateway. What about the transit and spoke gateways themselves? When you log into the transit gateway, and it doesn't matter which environment you are, GCP, AWS, and Azure, when you log into the transit gateway, then you will learn the spoke CIDR. If this spoke is 10.1.0.0/24, then you will learn over here at the transit. But this is not through any BGP or anything like that. It is through the software-defined route, which controller is programming into the transit gateways over here. And then what about the spoke? A spoke is going to learn the routes of any other spokes connected to this transit. For example, if this transit is also connected to a bunch of other spokes, then this spoke is going to learn about all those other spokes, CIDRs, or address spaces. It all actually depends if you have enabled one feature on your transit gateways in any cloud. And that feature is called a connected transit. This is by default segmentation that Aviatrix provides. Even though if you connect your spokes to your transit, it won't let you talk between the spokes unless you intentionally go and enable that functionality, which is called a connected transit. Okay, you have multiple spokes over here, right? You might have a spoke which is only for few users are connecting using the user VPN, and that's entirely different region, different country, right? Maybe it's in Europe somewhere, while everything else is in your US environment. For those kind of environment, you really don't need a transit at that point. What you can do, if you have something like that, then you can have your user VPN VPC over here. That is your user VPN VPC. And you have your spokes. You can attach that spoke to any of these transit directly. So You are not required to connect the spoke in that particular region or particular cloud to the transit, but it all depends on your use case. It all depends on the performance, latency, and all those kind of requirements that you have. The flow logs, you don't need to enable the flow logs over here anywhere. All the flow logs are enabled by default, and you can see the traffic between your applications by logging into the Aviatrix Copilot at any time. You don't have to turn it on, you don't have to turn it off at any time. All right, so right now you have your AWS environment, Azure environment, GCP environment, and now you know how the subnets, the routing tables, and the VPC routing tables, all those things works. How about when you have to communicate between the Azure, AWS, and GCP? At that point, you again log back into the Aviatrix controller and then create a transit connectivity between the Azure, AWS, and GCP. First, when you connect or when you log into the Aviatrix controller, and then you say, okay, my AWS transit should have a transit peering with Azure. Now, by just creating this transit peering, you will have bi-directional communication between them, right? Again, this is a standard encryption over here, which means 4 tunnels are going between these two transit environment. You can extend this thing to the GCP also. Let's say this is a GCP transit. By doing this transit connectivity, what you are saying or what you are going to start noticing in your transit gateways, all the routes learned from Azure Transit, all the routes learned from the GCP Transit on the AWS side, and vice versa. And again, if you allow this thing, this is another topic of the segmentation. If you allow, those routes will be propagated over to your spoke. Right now I'm showing only one spoke, but it could be many spokes. That's how end-to-end traffic can reach from one environment to another environment across regions, across clouds. That's how the routing works. All right, so this is all I have for today. Thanks for watching, and in the next session, I'll be discussing about the hybrid cloud connectivity.